Okay, so it's enter the compliance matrix in your calculator day. Okay, so I'm going to start with the quickest one, the inspire. So here's what you do. We have to call it something. Let's call this CMPL, compliance, okay? In the TI Inspire, type in, you got all the letter keys at the bottom, CMPL, and then parentheses EV, and then the matrix button right to the right of the 9, if you hit Control and press that button, you get something like this, and that's the function definition button. And now go to the matrix button. Okay, so CMPL EV. And it gives you a few matrix options. You want the one that looks like it draws it as 3 by 3. It sort of looks like a symbol like this. You see that? Luna, do you see that matrix button? Okay. And then when you click on that, it'll ask how many rows and how many columns. You want 6 and 6. Dan just showed me that you can use the tab button. Where's that tab button? Oh yeah. So to scroll around, and then you don't have to use the finger thing. Okay, and so now it'll give you, so now you'll have a matrix pop up like this with all the 36 elements just shown blank. And you're just going to enter in 1 over E, negative V over E, negative V over E, 0, 0, 0. Then negative V over E, 1 over E, negative V over E, 0, 0, 0. Then negative V over E, negative V over E, 1 over E. Then 0, 0, 0, 2 times 1 plus V over E, 0, 0. And then the last one. And then from that point on, this is always defined as a function in your calculator. And so now, for example, you can say, just type in CMPL, and I think if you do that now, it'll like highlight it or something, so it sort of shows you that it's a defined function. And you can enter in the values, like for example, enter in 200 times 10 to the 9, 0.3, hit enter, and it'll spit out this 36 element matrix for you. Okay, so now let's go TI-89. So for this one, go to Apps, Program Editor, New, and now you get this dialog box. The first thing it asks you is type. Do you want a program or do you want a function? I guess let's go function. So hit the right arrow and go down to function and hit enter. And then variable, that's a weird way to say it, but that's where you put the name of the function. So type in CMPL. And then it'll open the programming environment, and it says, so now it'll say CMPL at the top with parentheses, and your cursor is inside the parentheses, and in here you want to enter EV, because those are the arguments. Oh, okay. So now all you're doing is you're just defining this function. So now you can go get in between the beginning and end of the function. And in here, you're just going to type this. It's sort of tedious, but 1 over E, comma, negative V over E, comma, negative v over e, comma, 0, comma, 0, comma, 0, and now semicolon. And just let it break lines where it does, and you just keep typing as if it was all one line, okay? And so the next one then is going to be negative v over e, negative, 1 over e, negative v over e, 0, 0, 0, semicolon. And then negative v over e, comma, negative v over e, comma, 1 over e, comma, 0, comma, 0, comma, 0, semicolon. And then, so that's the first 3 rows. And then, and remember, like, don't ever hit enter, just keep letting it end rows where it runs out of space. And then 0, comma, 0, comma, 0. Then 2 times 1 plus v over e. I suppose use the multiplication symbol there. Semicolon. Nope. I missed the last 2 zeros. Now 4 zeros to start. And 1 0. And now the last row, 5 zeros. And 2 times 1 plus v over e. And now we're done, so close the bracket. And I think that's it. That's what I see. Okay, so now the TI-84, and I believe it's the same for the TI-83.
One of those calculators that doesn't have memory to do a matrix.
I can do, yeah, I think so.
Okay, so go to Program, and then go to New.
I can just do it from my top of it.
I'll pretend to follow along here.
Yeah, and then type in CMPL. I'll give you this back in a second. CMPL. And now we're going to enter these values. So you have to choose somewhere, some matrix in your matrix variables to enter. I'm going to put it in, I'm just going to put it in G, because that's the first one that you don't have something in already. So
you can clear the memory. All of those
okay.
I'm done with. So.
Oh, okay. Well, then I'm going to do C, actually, for compliance. So in matrix, go to edit, and it'll let you into whatever matrix and change the size to 6 by 6. And make everything zeros. Okay. Now go back into program. Really, this is what you should have done first, but okay, so go back into program, go to edit, go to CMPL. And for the first line, we are going to make one of the matrix elements, take this value we want. Oh, no, the first thing we want to do, so now you're in the programming environment. It says program CMPL, and you're going to click on program, input, output, prompt. And you're going to prompt the user for the value E. I guess on this one it's capital. And then you're going to do the same thing, prompt the user for V. And now that the program has those values, now you can say, okay, so now go back to matrix, hit second matrix, and scroll down to wherever you put that 6x6. And click on it, and you can see it. What it puts there is square bracket, C, square bracket. Nope, I did it in the wrong order, sorry. So before you do this, you actually want to go, so we'll go 1 over E, and then hit the store button. And now is when you want to put this in this value C. Go to matrix, select it. It'll put that square bracket with the matrix name in it on the screen. And then what you're going to do is parentheses 1, 1. And now you're going to do this a whole bunch of times, So now you'll go negative V over E. Did you get that? Oh, you don't have your calculator.
No, I just imagine how difficult that is to do all of this. It's like a choose your own adventure. Okay.
Okay, so now, once you've successfully done it once, then you just keep doing the same thing again. So now we're going to put this value into C1, 2. And we're going to put it into C1, 3. So that's the first row. Everything else is already zeros, so we can just leave that. And now the second row, negative V over E, put it in C 2, 1. 1 over E, put it in C 2, 2. Negative V over E, put it in C 2, 3. And now the third row, negative V over E into C 3, 1. Negative V over E into C 3, 2. 1 over E into C 3, 3. And now we're on to the last 3 rows. So you'll go 2 times 1 plus V over E, put it in C 4, 4. The same expression. Put it in spot 5, 5. Same expression into spot 6, 6. And so what it does now when you run this program, you give it the values of E and V, run the program, and it puts the compliance matrix into that spot. And you can go get it by using the matrix commands then. Okay, so let's call compliance matrix. So for everybody that doesn't have a TI-89, you're going to call it, okay, well, let me do it one by one. So for the Inspire, to call this function, you're going to type in CMPL, parentheses. Let's use 200 times 10 to the 9 for steel, 0.3, and hit enter. And you should get a matrix out. For the TI-89, go to catalog, F4, CMPL, and it'll write that on the command line, and then you'll enter the values of E and Poisson's ratio in here the same way as for the Inspire. So you can write this as 200 times 10 to the 9, comma, 0.3. Close the parentheses, hit enter, and it'll give you the matrix. And then for the TI-84, go to Program, Compliance, and run it. And it'll prompt you, you know, it'll say E, and you'll enter in 200 times 10 to the ninth. And then it'll prompt you for V, and you'll say 0.3. And then, depending on on how you ended the command, I think it'll either show you the matrix on the screen or it'll show you nothing. But either way, once you run it, that matrix will be inserted into whatever matrix you used when you programmed it. Okay. And so I think what you get here, everybody should get the matrix 5 times 10 to the minus 12, negative 1.5 times 10 to the minus 12, negative 1.5 times 10 to the minus 12, 0, 0, 0. Then minus 1.5, 5, minus 1.5, 0, 0, 0. Then minus 1.5, minus 1.5, 5. And then 1.3 times 10 to the minus 11. Nope. Anybody get that matrix? Okay.
I'm not seeing the sixth row on mine, and I can't tell it.
Okay.
Let's see.
Oh, if you click on that matrix that just came up and hit enter, it'll put it on the command line, and then you can scroll through and look at the values.
So I can't see the whole matrix just in the display.
Yeah, you just have to trust it.
Okay, but it is there.
It is there because you can see it, right? Okay, it is there. Actually, I think we might, let's see. Scroll. Yeah, I would scroll up. Shift.
Simultaneously down.
There's the last one. So.
Yay. Okay.
So I'm getting sentence. I got minus first, just rounded all the numbers to the first.
I mean, it's not that it's right, but like on the table, I was like so good by second. But it's fast.
Kind of like the.
Because if you hover the value, you can
I think it's probably just you need the multiplication symbol.
I can do
But the display is not.
Yeah, I just program it. I think I can.
Mine is 2.
What?
Yeah.
That's easier than actually looking it up.
It's the safety factor.
Can you program these from the laptop with Inspire?
Yeah, that was nice.
Is there a program?
I think I've been convinced enough to buy a $200 calculator. Or maybe I have the dark web.
They're so bad.
Because the TI
Why are they so bad?
you can program, it's free to program. So that's the only thing. I think I remember that one.
230.
This is dominated subscription programs. But you could go to Pirate Bay and get it for it's a cracked file.
Photoshop 2020.
Thank you.
Yeah, it only had 5 elements in the last row.
Oh, okay.
Anybody else want me to look at something? Or you got
Yeah,
it?
mine's still not
I
don't see anything.
It was my guy. So for this one, I have to like never touch this C matrix ever again, basically.
Correct,
Okay.
just for this semester, and if you ever want to do mechanics again.
Yeah, I'm pretty sure. I'm gonna try to program mine from the laptop. I think it might be a little easier.
Yeah, well, just remember, like, on tests, you need to be able to do this. You know, like, maybe we could, if you really want to use a laptop, I'm sure we could.
No, like do the writing the program, and then you just do the work.
Oh, and then zap it over.
And then you
Oh,
zap it
that's-
over instead
Yes,
of.
that's a better way to do
It's
it.
so,
Yeah,
if I get that to work, I'll give you the,
yeah,
I'll email you the files. So you can
I got
forward to people.
yeah, that would be awesome. Luna, you got that working? Okay. Well, so now, what if you, so now we have that matrix. Now let's do this. Oh, that's riveting video there. That was recording the whole time. So now what if you have this state of stress? So let's say we have compression here of 10 megapascals and tension here of, 10 megapascals. Let's make this 8. And tension here of 15 megapascals. And then let's put in some shears. So let's do 1 times 10 to the 6. And this one, let's do 5 times 10 to the 6. And then this one, let's do 6 times 10 to the 6. Okay, so we're going to assume that this is steel and this is the strain, this is the stress at some point inside, you know, that's made out of that material. And we want to figure out what the strains are. So we want to find that Voigt strain. So to do that, this is a stress tensor. Would be negative 10 times 10 to the 6, positive 1 times 10 to the 6, positive 5 times 10 to the 6. Then you have symmetry here, says this is 1 times 10 to the 6. The YY stress is 8 times 10 to the 6. The YZ is negative 6 times 10 to the 6. And now symmetry, and positive 15 times 10 to the 6. And that means that the Voigt stress is negative 10 times 10 to the 6, positive 8 times 10 to the 6, 15 times 10 to the 6, negative 6 times 10 to the 6, positive 5 times 10 to the 6, positive 1 times 10 to the 6, and the Voigt strain then is just going to be that matrix that your program defined times this thing. And that should give you
Obviously, that's
200 times 10 to the 9. And if this works, you should get negative point. I'll just write them up.